So students, today in this video we'll discuss refraction of a plane wave. Uh, this is the concept from your wave optics chapter. Either refraction of a plane wave or reflection of a plane wave, one question definitely comes in your exam. So this section is very important and you should go through it. Refraction of plane wave, and we consider the hygiene principle here, considering light as a wave. So instead of a single ray, here what we will do, if wave front AB, let's say AB is a wave front, here it is A, here it is B. So this is a wave front which is propagating in this direction, and it will strike the medium 2. This is medium 2, this is medium 1, right? And this is rarer to denser. So you can also, the question comes also from denser to rarer, also the question comes. So you have to prepare for that. And if you require help for the denser to rarer or the reflection one, similar way you have to proceed. If you find any difficulties, you can write in the comment box so that I can make another video for the reflection and the refraction in the denser to rarer. So here we are considering rarer to denser. Now just try to understand the logic. It will be very easy. So what is the logic here? The logic is that it's a wave front, right? So AB is a wave front which is coming. So see carefully. So if you look carefully, that the wave is moving, means both the rays here and here, A and B, it's a wave front. So both are moving in the same speed. But it is coming with an angle. So let's say this is 90 degree. And this will be angle of incidence, your I. This is 90 degree. So as the incident ray at A will get inside the medium 2, it should come like this. It will bend towards the normal because rarer to denser, and this will be a refracted angle of refraction. Now the key point is, now just listen carefully. This is very key, very important in this derivation. That important point is that here the light is going inside this medium, and the other side of the wave front, which is at this B, which will travel and reach in the same time here. Let's say it is taking tau time to reach here. So within same time, ray A will get inside. It will go inside the medium. But at same time tau, B will reach here. But both are traveling with a different speed. Remember, because medium 2 and medium 1 are different, so they will travel with a different speed. So the amount of time the B side of the wavefront has taken to reach here, so the distance will be, how much distance it has traveled. Distance will be v1, medium 1, the speed 1 into tau. This much of distance it has covered. Obviously it will be tau into v2. Obviously the speed in the second medium, denser medium, will be less, so v2 tau will be less h compared to, so the distance here will be slightly less. So what you will do, you will just cut it and you will draw this distance tau v2, and you will join here. Okay, now this will be right perpendicular because this is the tangent. So if this is your the tangent to this line, this will be perpendicular. So here it will be perpendicular, right? So we have to prove what? Refraction, law of refraction here. Remember, what you should know your aim, what you are going to do. So here our aim is to prove the refraction. So refraction means we have to prove the Snell's law here. Are you getting? So we have to prove the Snell's law here. We have to prove the Snell's law here. So look at the two triangles. Let it name it C. So now see the triangle ABC and triangle, let's say M. This one is triangle AMC. In this two triangle, you see which what are the sine I and sine R. Okay, so if this is 90, because we have to prove this one, sine I by sine R is a constant, or you can say mu2 by mu1. You have to prove this, right? You have to prove this. So what we'll do, we'll find out sin I and sin R in this two triangle, ABC and AMC. ABC is also, this is 90 degree. This is 90 degree. Both are right angle triangle. So what is I in this ABC triangle? Now if this is I, if this is I and this is R, so this is 90. This is, if this is I, so you can write, can you write that this angle is also I? Can you write that? And if you can write, just imagine why you can write this I, because this one is 90 degree. So this is I, this is 90 minus I. Are you getting? And again this is 90, this is 90 minus I. So what will be this angle? I, obviously. If this is X, so X plus 90 minus I equal to 90. 90 cancel, so X equal to I. You can prove easily, right? So this angle is I. Again you have to prove that this angle is R. Can you prove it? So using your high school mathematics, 8-9 mathematics, you can easily prove this, right? Or shall I give you a hint? So let me give you a hint. So this is R. This angle is angle of refraction, and you have to prove that this angle is also angle of refraction. This is 90 degree. Same similar way you can move. This is 90, this one plus this one also 90 degree, right? This one plus this one is also 90 degree. So this one is 90 minus R. This one is 90 because total is 90. This is R, so this one is 90 minus R. So if 90 minus R, this is 90, so this one will be R, obviously, because 90 minus R plus R, it will be, should be 90, 90, 90, 18, right? So simply you can prove that this is R and this is I. So in triangle ABC, look at triangle ABC. Look at the triangle ABC. It's a right angle triangle. This is I. So what will be sin I? Sin I. So in triangle ABC, sin I can write, sin I is sin theta. What is sin theta in a right angle triangle? In a right angle triangle, if this is theta, your sin theta is P by H. Sin theta is P by H. This is perpendicular, this is H. P by H is sin theta. Okay, so P by H. A very simple thing. So here sin I, you can see sin I will be, here is P. P is this one, BC by H is AC. And from triangle AMC, what is sin R? Sin R you can write, this is sin R. So P will be AM divided by AC. Now if we write sin I by sin R, if we write sin I by sin R, sin I by sin R, so your ABC by AC divided by BC by AC is AM by AC. AC get cancelled, AM, it's BC by AM. BC by BC by AM. Okay, so BC by AM, now see, BC is what? BC is V1 tau. BC is V1. This is timer, okay? This is time. This tau is time. So this is V1 tau. AM is V2 tau. Both are taking same time. From B to C, it's taking same time, and from A to M, it's taking same time for the light to reach from A to M. So B1 by B2. Now the definition of refractive index is N is C by V. So for V1 I can write, so N1 equal to C by V1, or V1 I can write C by N1 divided by C by N2. So C gets cancelled, N2 will be the numerator, so it will be N2 by N1. It will be N2 by N1. So hence it's proved that sin I by sin I by sin R, hence it is proved that sin I by sin R is N2 by N1. So this is the proof of your this is a proof of the refraction of light by a plane wave. So if we are considering light as a plane wave, let's say with a wave front AB instead of a single ray, okay, so then also we proved easily that it is obeying the Snell's law, that is sin I by sin R is a constant, or you can also write like this, cross multiplying N1 sin I equal to N2 sin R. Okay, so just cross multiply. So this is, if this is obeyed by the wave, that is plane wave, so definitely it is obeying the law of refraction, and so hence plane wave also exhibit and also obey the law of refraction, and this is the proof. So if you require the help of reflection or the your again you remember, this is what we have proved. This is for rarer to denser. We have proved for, this is rarer, light traveling from rarer to denser. Light traveling from rarer to denser. If it is from denser to rarer, similar procedure, the diagram will be little bit different if you look carefully, because it is traveling in rarer medium. So BC, this length is greater than AM. Even if it is taking same time from B to C, the BC distance is less than AM. BC is less than AM. BC distance is less than AM. So I'll make another video for the proof of reflection. Thank you for watching. See you on the video.